What if the first computer was not built in the modern world, but existed 5,000 years ago, made of clay, not recording calculations, performing them? I want to start with a tablet, not the famous ones, not the king list, not the Epic of Gilgamesh, not the Venus observations, a category of tablet that sits quietly in collections across the world, in the British Museum, in the Oriental Institute, in the Louvre Museum, in the Istanbul Archaeological Museum, studied for over a century, translated, published, discussed in academic literature, and yet they contain something the academic world consistently notes and then avoids exploring. These tablets perform calculations, not record calculations performed by a human. They perform them. The tablets contain mathematical tables, pre-computed results for multiplication, division, square roots, cube roots, and reciprocal values, organized in a format designed for one purpose. Look up. You bring in numbers. You find the entry. You read the answer. This is what a calculation device does. This is the functional definition of a computational tool, a system that performs operations and makes results available without requiring the user to perform the calculation. The Sumerians had this 5,000 years ago. The YBC 7289, held at Yale University, dates to around 1800 BC and contains a calculation of the square root of 2, accurate to 6 decimal places, 1.41421,356, the irrational number that describes the relationship between the side of square and its diagonal, inscribed in Babylonian sexagesimal notation on a clay tablet, over 3,000 years old, with a precision not exceeded in the Western tradition until much later. But I want to go further back, because this is not the beginning. The Yale tablet, impressive as it is Babylonian, a later development of something much older. The Sumerians were already doing this centuries earlier. Their tablets contain the same structure, pre-computed tables, organized for lookup, covering the mathematics required for administra, engineering, and large-scale coordination. During the UR3 period, from 2112 to 2004 BC, scribes were managing labor, agriculture, livestock, construction, across multiple cities simultaneously. The mathematical demands were massive: rations for thousands, volumes for building, areas for land, yields for agriculture. Everything had to be calculated. And these tablets were not theory. They were tools, working tools, used daily, and their sophistication has never been fully explained. The standard explanation says, this knowledge developed gradually, over generations, driven by necessity, refined step by step. That explanation sounds complete, but has a problem acknowledged, and then ignored. The sexagesimal system, base 60, the core of Sumerian mathematics, appears fully developed from the very beginning, not primitive, not evolving, already advanced, even in the earliest proto-writing tablets, before writing itself fully formed. This system is already there. The most sophisticated part appears before the system that should have created it. And what they built with it was not just a recording system. They built lookup tables, pre-computed answer systems, designed to remove the burden of calculation from the user. This is not just mathematics. This is architecture, the architecture of computation. I am not saying there were electronic machines. I am saying something more precise. They understood that computation can be separated from use. Answers can be generated in advance, stored, and retrieved without recalculating. This is the foundation of every computational system. The multiplication table is the simplest example. Every student who memorizes it is using a lookup system. The Sumerian tablets extend this idea far beyond that. Reciprocal tables turn division into multiplication. Square root tables solve geometry instantly. Cube root tables extend into 3 dimensions. Tables of squares and cubes calculate area and volume. Together, they form a complete system for a complex civilization. And this system appears at the beginning, not the end, not after centuries of refinement, but already organized, already structured, already complete. Now consider the Plimpton 322, held at Columbia University, dating to around 1800 BC, a table of Pythagorean triples, sets of numbers that satisfy A superscript 2 plus B superscript 2 equals C superscript 2. This defines right triangles. The Greeks are credited with formalizing this 1,000 years later. But this tablet is not proving the theorem. It is using it systematically across multiple values, organized, deliberate, far beyond simple construction needs. This is not discovery. This is system-level knowledge. Now look at how this knowledge was preserved. Through the Sumerian scribal schools, the Aduba, these were not casual learning spaces. They were structured institutions. Students copied tables, checked them, then produced new ones. The system was standardized across cities, across generations. This is not isolated intelligence. This is infrastructure, a system designed to preserve, standardize, and distribute knowledge. And here is the critical point. The system appears fully formed. From the beginning, the school exists, the curriculum exists, the mathematics exists. But where did it come from? You do not build a system to preserve knowledge before that knowledge exists. The Sumerians give an answer. They say it came from the Apkallu, beings from the sea, who taught humanity everything needed for civilization, including mathematics. Not symbolic, not metaphorical, explicit. Now move forward to the Antikythera mechanism, a mechanical calculator, predicting eclipses, tracking astronomical cycles, with complex gearing. When discovered, it was considered impossible for its time, because nothing similar appeared for over 1,000 years. But its mathematics came from Babylon, which came from Sumer. The idea did not change. Only the medium, clay, to bronze, to silicon. The principles stayed the same. Compute first. Store the result. Use it later. This is computation. And it begins here, 5,000 years ago. So now the question, who created the first tables? Before the schools, before writing, before systems, who calculated the square root of 2 to that level of precision? Who generated entire mathematical systems before history records them? The tablets give an answer, the same answer, every time. The real question is, why do we keep refusing to take it seriously?